All right, so here we are with example 7. I've cleaned this up a little bit and let me see. Yes, I have something to write with. It may all be the same color because I don't see how to change it. All right, given cosine is 2/3. So immediately they said cosine is 2/3. So not only do I have cosine, but immediately I know I have 3/2. And this thing is going to mess up a little bit on me. We'll have to see how it goes. All right, so I've taken care of this, and it means it's positive. So remember, all stairs take caution. All stairs take caution. So cosine could be here, or it could be here. The next thing this says up here is that theta is somewhere between 3 pi over 2 and 2 pi. So if it's at 3 pi over 2, 3 pi over 2 is this line right here. Well, if it's going to let me write, here's 3 pi over 2, and here's 2 pi. So if it's got to be in there, if it's in between these, we have no choice. It must be coming out this direction. All right? So here we go. We have, interesting, we have theta, our right angle, and cosine is adjacent over hypotenuse. So we need to find this side over here. So we're going to go over here. We're going to go, okay, I've got 2 squared plus b squared equals 3 squared. And that's going to give me 4 and 9. So b, if I subtract 4 from both sides, I get b squared is 5. So b is the square root of 5. So this side is the square root of 5. So that means I have, let's double check here though, because we have something funky going on. We have the whole idea that, wait a minute, this whole thing, this is going out positive in this direction, but this is going down in a negative direction. So don't forget, this has to be a -5. All right, so we're going to have the opposite over hypotenuse, which is negative square root of 5 over the hypotenuse, and then -3 over the square root of 5. And we can't leave the square root of 5 on the bottom. I hope you've done enough of these that you can go, oh, that's -3 square root of 5 over 5. All right, tangent's going to be opposite over adjacent, which is square root of -5 over 2, and, well, I didn't get the square root in there. Hello, square root. There we go. So, and the opposite of that is -2 over the square root of 5, which you should know is -2 square root of 5 over 5. All right, next problem. All right, given cotangent is equal to -3/4. Okay, so cotangent is -3/4. So that means I know its opposite over here is going to be -4/3. Okay, so cotangent's negative. Where is cotangent negative? Well, let's see. All stairs take caution. Cotangent is negative here, and it's negative down here, because only tangent plus cotangent are positive in this corner. So I know it's not going to happen here. It's not going to happen here because this has got to tell us. Let's see where this is saying. In between pi over 2 and pi. Pi over 2 is right here, and pi is right here. All right, so obviously it's got to be out this way, okay? And it didn't like that. Let's see what goes away. I don't know what's going to go away. There it goes. Well, good, it was an ugly side anyway. There we go. Good enough. All right, so find the value of the other 5 trig functions. Well, let's get it labeled. Tangent is opposite over adjacent, 4 over 3. And this is where I want to look and say which one's going to be negative. It's this one that's going to be in the negative direction, and I just lost my negative. Wow. And I bleeped it to the next page. Didn't mean to make that happen. All right, so then I need to do, this is a 3, 4, 5 triangle. You can do Pythagorean theorem, but I can promise you that really is 5. So opposite over hypotenuse, 4/5, 5/4. Cosine, adjacent over hypotenuse. And the opposite of that, -5/3. All right, going on to special right triangles. Okay, now special right triangles, if you're not here for this day, I'm so sorry. This is one of my favorite days. I love doing this in geometry. I tell them this in geometry, but they're tired. It's the end of the year and they don't always remember. So I am going to tell you this. Back in the days of Pythagoras, Mesopotamia, those kind of things, people were really thinking about squares and circles and things that had equal sides or circles that have no sides. All right. And so if this square is a 1 by 1 square, they said, you know, wouldn't it be kind of cool? We have the Pythagorean theorem thanks to our good old buddy Pythagoras. So what would this hypotenuse be worth? Well, 1 squared plus 1 squared equals c squared. Well, those are each one apiece. So this is 2 is c squared. So c is equal to the square root of 2. Now what this does, this is true not only for this square, but any square we have. If it was 4 and 4, this answer would come out 4 squared root of 2. And they were like, dude, that is really cool. So what I do is I either turn this 1 here, I either make it an x or an a. You can make, it just depends on what variables they give you. So this could be x, x, and x root 2. It could be a root 2. So that's all we need to figure out any side given. So if you have a 45, 45, 90, to where each, oh, well, let's go back. Why do these have to be 45? They have to be 45 because this was a 90 degree and it was split in half, cut exactly in half. If two sides are congruent, they're base angles, and these would be base angles, they're congruent. That has to do with being an isosceles triangle. So 45, 45, and two congruent sides, that's a 45, 45, 90. This side is x, this side is x, because that's the isosceles part. And this is x times the root of 2. All right, so how do we use that? Well, here we have, you see how I have an x and a y here? This is why I said it just depends on the problem if I want to use x's or a's. And this is an example where I want to use an a. So my 45 is here, and the hypotenuse, by the way, there is a 2 on the hypotenuse. All right, so that means that we have a, and I don't know why it does that, a root 2, and this was a. Okay, so we have a root 2. So the side that's given to me is right here. And what I know is that a root 2 is equal to 9 root 2. You with me? So then we divide by the square root of 2, and I'm going to solve for a. Divide by the square root of 2. A is equal to 9. My a looked more like a 9, and it's a pain to erase. So these canceled. I get 9. So if a is 9, they're both a. So guess what? I know both sides. All right, looking at this one. Again, an x is being used, so I'm going to use a, and a root 2. I hate this. A. Yeah, you got to love it. Technology. A root 2. Oh my gosh, I got it. So first a that they give me, or the one side that I know, is that a is equal to the root of 2. Well, since this is an a, I automatically know what y is. It's square root of 2. All right, now what's going to take me a minute to find is the x. So x is equal to a root 2. I love it. A root 2. But a itself is the root of 2. That means I have to plug it into that a. So this is equal to the root of 2 times the root of 2, which is 2. So that means x is 2. Okay, there you go. All right, now there is one more, and the other special right. Sorry, this is going to take a long time, but I do want to show you how to do this one. Now, this is an equilateral triangle. Again, magic happens when all sides are equal. All three angles will be 60, but if we drop this and we split it exactly in half to where we get a 30 and a 30, and remember, these two sides are equal here, what happens is we get a right angle down here, and if this little piece right here, great, this little piece right here is 1, then that means this side over here is 1, so the whole side is 2. So that means we have a 1 and a 2. Wait a minute, we're on a hypotenuse again for this right triangle, not this one. We could use one side or the other. I'm going to use the white one that's clear that I didn't scribble in. All right, so we have 1, 2, and now I need to find this side. So I'm going to say 1 squared plus b squared equals 2 squared. All right, so 1 plus b squared is 4. B squared is 3. B is the square root of 3. All right, so I'm going to show you how I keep these in my memory. I have the square root of 3 is always adjacent to 30 degrees because the hypotenuse always has a 2 on it. Okay, if you look back at a 45, there's a square root of 2 on the hypotenuse, and the other side has to be a 1. So it's 1, 2, square root 3. All right. Now, of course, we can't have 1, 2 square root of 3. We have to have x, 2x, and x root 3 because every side, of course, is not a 1. The small side isn't a 1 for us on everything. So let's look at these next examples. All right, so I'm trying to hurry through these. Okay, so I've got to label this. This angle is my 30-degree angle. So I've got to label it. This side, my smallest side away from 30 is my, I can use x, it's okay. And the hypotenuse gets the 2. And this side over here gets x root 3. Okay, look at the side I know. Oh, this was not pretty numbers. Why did I do this? What was I thinking? So x is equal to 3 over 2. So that means u is 2x because that's the side I labeled as 2x. All I have to do is fill that in. It's equal to 2 times 3 halves. Guys, you've got to get better at multiplying with a fraction. This is over 1. These cancel. Your answer is 3. All right. So this answer is 3. Lastly, v is equal to x times the root of 3. Well, I don't have just x, or do I? Oh, wait, I do. It's right there. So all I'm going to do is substitute this in with 3 halves times the square root of 3. And the way that we actually write this is 3 square root of 3 over 2. It's unusual to put it like a fraction by a whole number. So I'm just going to say that's equal to 3 square roots of 3 all over 2. All right, going to the last one. Again, I need to label it right. So that means this side over here is my 30. Here's my hypotenuse. And I've got x's in here already. So I'm going to use an a instead. So I have 2a. I have 2a. And it's just arguing with me. 2a, a, and the side by the 30 is a root 3. And this side was a, and golly bum, rawr. Okay, frustrations. There we go, a to a root 3. Now, the side that's given to me is this one right here. So a root 3 equals 5 root 3. I am going to divide by the square root of 3 because I want to solve for a. I always want to get the a or the x by itself. So a is equal to 5. All right, so if a is 5, wait a minute. I know y is a. If y is a, that answer is just 5, and I'm done with that one. All right, so 2a, if x equals 2 times a, but I know a is 5, that's just 2 times 5, which is 10. All right, I'm going to stop right here because we need to take a